Hey, here's another chance at your test review. Please check all your answers and do remember that your test is Friday. Okay, moving on to the first question. Okay, for the first problem, we do need to find the period. And remember, the period can be found by saying 2 pi over b. And b for this particular problem will be 2. So the period is going to be pi. Now for us to find what we call our quarter points, or our x values, we will need to take that period and divide it by 4, which is going to give us pi over 4. So I know in my t-chart, I will need to go up by pi over 4 each time. Now we are still starting at 0, and since we don't have a phase shift, we can go ahead and label the other part of our t-chart y. Now as we're going up, we're going to say 0 plus pi over 4, just pi over 4, and then we will have 2 pi over 4, and yes, you can reduce that to pi over 2 if you want to. That's strictly up to you. Then we have 3 pi over 4, and finally we have 4 pi over 4, which again will reduce to pi, but that's only up to you if you wish to reduce that. To find your y values, you have a couple of choices. One would be to go through and plug in each one of these values that we have for x. If we do that, notice if we plug in 0 in place of my x value here, if we go back and we plug back in all of those x values, you will get y equals 3 sine of 2 times 0. And you would multiply 2 times 0, get 0, sine of 0 is still 0, and then 3 times 0 is 0. That is one way of doing it, and you can repeat all of that all the way through these. But there's also another way, and it is a little faster, and what we can do is refer back over to the unit circle and remember our basic values for sine and cosine. And do remember how the point here is 1, 0, up here 0, 1, over here negative 1, 0, and finally down here 0, negative 1. And if you'll remember that everything from our trig function over to the end of the parentheses will take on each one of those values as we go around the unit circle. So for pi over 4, we certainly can plug in this pi over 4 up here and say 2 pi over 4, which is pi over 2, and sine of pi over 2 is up here at 1, which then we would say 3 times 1 is 3. But when our problems get a little more complicated, we sure don't want to have to go through this each and every time we get a value. So it might be a little faster for us to focus on, since we're talking about sine, to focus on those y values. So the next y value would be 0, and 3 times 0 is 0. And then the next value that we would get is negative 1. So 3 times negative 1, negative 3. And finally, all the way around, we're back at 0. And you're more than welcome to do this each and every time you have a problem. So now for problem 2, again, we start it the same way. Your period equals 2 pi over b, and our b value is 1/3. And remember, when you divide fractions, you do multiply by the reciprocal, so that gives me a period of 6 pi. Now to find our x values, we do our period over 4, so that's going to give me 6 pi over 4, which does reduce to 3 pi over 2. Now we need to build our t-chart, and we can go ahead and label our y values also because we do not have a phase shift. Now the phase shifts are coming up, but with this one we don't have that. We are starting at 0, and we will add 3 pi over 2 each time. So we now have 3 pi over 2. Then we have 6 pi over 2. And again, you're welcome to reduce that to 3 pi if you want. And we also have 9 pi over 2. And then finally, we have 12 pi over 2, which again, you're welcome to reduce that. And if you do, you see we've completed the period here. We're all the way to 6 pi. And again, if we want to use what we just saw in the earlier problem, we can just focus on all of those cosine values, which would be the x values. So again, if we go around our unit circle, we're just focusing on the 1, 0, the 0, 1, negative 1, 0, and then down here 0, negative 1. The negative didn't show. Okay, and again, we're looking at our x values. So we're going to start here with our 0, and if we plug in, of course, we see we have 1/3 times 0, which is 0, and cosine of 0 is 1. So indeed, this box does change to 1. So we have negative 4, and then our box will change to 0, and negative 4 times 0 is 0. And then we go to negative 1, so that's going to be a positive 4. We're back at 0, and then all the way back around is at negative 4. And again, if this is confusing you, by all means go back and plug in these values, and you will see that they do work. Okay, so for number 3, again, starting the same way, we do need to find the period. And the period for this problem, we're going to have the period equals 2 pi over b, and b is sitting right here, so over 1, which is 2 pi. Now, just like the other ones, we need to take our period, divide it by 4, so this is going to give me 2 pi over 4, which is just going to be pi over 2. So now we have what our x values will go up by. So when we're going through here, notice we do have a phase shift with this problem. So we are going to have 2 different x values. We'll have our x values that we start with, and then we'll have our x sub 1 x values that we'll end up finding. And then finally, we'll go through and we'll find those y values. So let's go through and find our first x values. So we will start with 0, and if we're going up pi over 2 each time, we have pi over 2, then we have 2 pi over 2, 3 pi over 2, and finally 4 pi over 2, or 2 pi. Again, you're welcome to reduce. But remember, this problem, we have a phase shift, and we have a minus pi over 3 on the inside, which means we're moving to the right pi over 3. So I need to go through and add pi over 3 to all of my x values because we're moving our graph to the right pi over 3. So 0 plus pi over 3, well, that's going to be our pi over 3. And then pi over 2 plus pi over 3. Remember, we had this different way of adding these fractions. We could say pi over 2 plus pi over 3, and we could say that's 3 plus 2, which is 5 pi over 6. Make sure you multiply those denominators. So if we repeat this process, again, we're going to have pi, or 2 pi over 2, which is just pi, and we can think of that over 1, plus pi over 3, well, that's going to be 3 plus 1, which is 4 pi over 3. And we can continue on with 3 pi over 2. So if we add that, 3 pi over 2 plus pi over 3, again, that's going to be 9 plus 2, 11 pi over 6. And then our final one back over here at 2 pi or 4 pi over 2, let's see what that's going to be. We have 2 pi over 1, I just reduced that, plus pi over 3. So that's going to give me 6 plus 1, just 7 pi over 3. So now we have all of our x values. We're going to go through and find our y values, and we're going to use the same process that we did earlier. So keep in mind, and I'm going to go erase some of this scribblings. So up here, when I go through, remember that we don't have to plug in. Now we're welcome to do so, but we don't have to. We can focus on everything from our trig function all the way to the close of the parentheses. We'll take on those y values. So sine always starts at 0, so 5 times 0 is 0. 0 plus 2 is 2. And then we go to the next one, and that's going to be 1, so that's going to give us 7. We'll be back around to 0, and then we're at -1, so that's going to give me -3. And then finally we're back around to 0, so that will give me 2. Okay, moving on. Okay, so moving on to the next set of problems. Okay, for these problems, we had to rewrite this, so we have 7 cosine. We do need to factor out the 4x minus pi over 4, and then minus 1. You won't have to remember to factor that out on the test. It should already be in that form. Then we're going to have 2 pi over b, which does reduce down to be pi over 2 for our period. And then to get our quarter points, remember we need to take pi over 2, and we need to divide that into 4 parts. And so that's really going to be pi over 2 times 1 over 4. So our x values that we get from that should be pi over 8. Now we're going to set up our t-chart, and this time we do have a phase shift, so we are going to have an x sub 1 here, and then we'll have our y values. So starting at 0, we will add our pi over 8, and then we'll have our 2 pi over 8, 3 pi over 8, and then finally 4 pi over 8. That should be our x values. Now keep in mind we do have a phase shift here. A phase shift, and we're moving to the right pi over 4. So we need to pick up all these x values and we need to adjust them to the right pi over 4. So 0 plus pi over 4 is going to be pi over 4. And then we have pi over 8 plus pi over 4. And we can go through our other trick again. So we have 4 plus 8, which is 12 pi over 32, which you're welcome to leave if you want, or you can reduce that, either one. You can take a 4 out of top and bottom, and that would be 3 pi over 8. The next one, 2 pi over 8, so we're going to take pi over 4. We're going to add pi over 4. So again, what is that going to be? 2 pi over 4 or pi over 2. We also have 3 pi over 8 plus pi over 4. So that looks like that's going to be 12 plus 8, which is 20 pi over 32. And that'll reduce to 5 pi over 8, or you can leave it 20 pi over 32, either way. And finally, we have 4 pi over 8 or pi over 2 plus pi over 4. So that's going to be 4 plus 2, or 6 pi over 8, or 3 pi over 2. Oh, I can't quite see that. Now to go through and find your y values, we do need to keep in mind what all of those cosine values will be. and we will be blocking in everything from that cosine function to the end of the parentheses, and we have to remember what the cosine values are. Cosine would start at 1, so we would have 7 times 1, and then that's going to give us 7, and 7 minus 1 is 6. And then we have 0, so that's going to give me a negative 1. And then we're back around to negative 1, so that's going to give me negative 7 minus 1 is negative 8. And let's see, then we're back at 0, so we have negative 1, and then all the way back around should generate 6 for us. And again, I'm finding all those values. Either you can plug in all these x sub 1 values, or you can go through and just grab your x values from the unit circle. Okay, moving on to the next problem. Again, more of the same. So we do need to find the period, which is 2 pi over b, and our b in this problem is 2/3. That's a strange one. So we will go through and let's see, that's going to be 2 pi times the reciprocal, so 3 over 2. So it looks like the period is going to work out to be 3 pi. Okay, so after we've gone through our 2 pi over b, and we've multiplied by our reciprocal, do remember to get those x values, we need to do our period over 4. So we're going to get 3 pi over 4. And so this time we don't have a phase shift, so we can go ahead and hopefully go through our x and y values. So we're going to start at 0. 0 plus 3 pi over 4 is 3 pi over 4. Then we go again, we have 6 pi over 4, 9 pi over 4, and then finally 12 pi over 4. And you can reduce those if you want, or leave it just like that, either one. And then we go through to find our y values, and since we don't have a phase shift, again, we're just taking that amplitude of 4 and multiplying to all of those sine values. So if we do that, sine starts at 0, so we have 0, 0. Then sine goes to 1. 1 times 4 is 4. And then we're back around to 0, negative 4, and then finally all the way back around to 0. Okay, for the last problem like this, again, we're going to have our period is going to be 2 pi over b. B in this problem is 8. So that will reduce to be pi over 4. Okay, and then we do need to take our period, divide it by 4. So we're going to get pi over 4, and then we're going to divide that by another 4, which is going to give us pi over 4 times 1/4. And so that should end up giving us pi over 16. So we will be going up by pi over 16 each time. So let's go ahead and generate our t-chart. We're going to find those quarter points. So we have 0, then we have pi over 16, 1 pi over 16, 2 pi over 16, and then we have 3 pi over 16, and then 4 pi over 16. Okay, and now since we don't have a phase shift, we can go ahead and look at all of those values that cosine has, and cosine always starts at 1. So negative 2 times 1 is negative 2. Then let's go up to 0, and then back at negative 1, down at 0, and then all the way back around again. And so that's going to be all of your y values. Okay, moving on to the next type of questions. Notice here we had to go through and use their given characteristics and come up with the actual function. So for number 7, for us to have an amplitude of pi over 6, so most of us, we can get started with this and say, well, I know that amplitude goes there in the front. That was A. We're talking about a cosine function, so that's okay. Now, to figure out the period, remember that 4 pi is actually saying your 2 pi over b was equal to 4 pi. This is not your b value. Period is not b. So that's important for us to remember. So here, to figure out what that is, b would have to be a 1/2 in order for me to get a period of 4 pi. So here, cosine would be 1/2, and then of course our x value. And notice there's no phase shift, no vertical shift, so this should be, for number 7, our final part. Now, if you're not sure about why b had to be 1/2, we certainly can come down here and set up a proportion. And so let's look at that for just a moment, because that might help some of us see why in the world that had to be 1/2. So let's look at the proportion we could do. We can say 2 pi over b had to be equal to 4 pi, and we're going to put that over 1. So if we treat this as a proportion and cross multiply, we have 2 pi equals b times 4 pi. And then I can divide both sides by 4 pi, divide over here by 4 pi, and notice that that's going to cancel, so that leaves me with b equal to 2 over 4, which is 1 over 2. You can do that, or you're more than welcome to reason through this to find what that period has to be, or what the b value, not period. Okay, so let's try number 8. And again, number 8, we're told that we have a sine function, amplitude 5, so we can get this started. We have y equals 5 sine, but now we're told that we have a period of 2 pi over 3. So that means that I had 2 pi over b had to be equal to 2 pi over 3. So what does it look like b is going to have to be? It looks like b is going to have to be 3. And then we have that times x. And then notice we have no phase shifts, but we're moving this all up 2. So we're going to have a plus 2 out here to the side. To keep things separated, it might be a good idea to put your angle inside parentheses, so we know that that plus 2 is really out here in the end. Okay, so let's try number 9. And let's see, number 9, let's go through each step, because here we've got both things going on here. We've got both a phase shift and we have a vertical shift. So for number 9, we know it's y equals cosine, let's see, amplitude of 15. So we have 15 cosine, and then my period is 4 pi, which is like what we had up here with number 7. Okay, so I'm going to get rid of that parentheses because we want to put that b value on the outside. So our b value, again, just like the top, we're going to have 1/2 times, and then we have our x, and we have a phase shift. We're moving left, but remember, with a phase shift, that left, we want to say minus, but it's the opposite, so it's going to be plus pi over 2, and then we're moving all of this down 10. So that should be what we're looking at. That is cosine there. Okay, so moving on, number 10, same idea. We have y equals, our amplitude is 2/5. We have a period of pi over 3. Now our function sine, so let's see what our b value is going to have to be in order for this to happen. So let's see, 2 pi over b, and that has to be equal to pi over 3. Well, if you don't see it right off, we can do what we did earlier with this particular problem, and we can cross multiply. And so if I do that, I get 6 pi equals pi times b. So we've got pi times b, and then we'll go through and we need to divide both sides by pi because we are solving for b. And so notice our b value has to be 6. So we're going to have our b value sitting out here of 6. And you can check that in your head. 2 pi over 6, yeah, that's pi over 3, so that's right. And so here we have x. We're moving right pi over 3, so we need to do minus pi over 3. And then there's no vertical shift. So this would be our final answer for 10. Okay, moving on to the next set of problems. We need to look at the graph and we need to assume no phase shifts have taken place. That way we don't run into an infinite amount of possible answers. So it's a good idea to know where sine and cosine start, and just like earlier with our graphs, it was good to know that cosine started at 1, sine started at 0. So that tells me immediately that for number 11, if I'm starting way up here, I'm probably talking about a cosine function. So up there, cosine, so I would start out by saying, well, I know that's a y equals, and it looks like my amplitude might be 2. This is a cosine function. There's no phase shift, so I don't have to worry about adding or subtracting anything. Now, it would be good if I could figure out what the period is. And remember the period, 2 pi over b. So let's look to see if we're starting here, we don't repeat until we're way over here at 4 pi. Because again, cosine is going through its cycle. So I know 2 pi over b for this particular problem had to be equal to 4 pi, and just like the earlier that we saw that we would have to have a 1/2 for our b value, and so it looks like this might be y equals to cosine 1/2 x. Okay, using the same idea over here for number 12, we would have y equals, and we are starting here at 0, but it looks like a sine function, but it looks like we're flipped upside down a bit. So I know there's probably going to be a negative involved, and it looks like I'm hitting down here at -2. So -2 sine. And we need to see what the period is, and notice here that didn't run off, but that should be all the way at 2 pi over 3. So it looks like we're going to start repeating here, doesn't it? So if that's the case, then I know my 2 pi over b has to be equal to 2 pi over 3, so b has to be 3. And there's no phase shifts, and it doesn't look like this has been picked up and moved any which way, so we can just finish this with our 3x. Alright, so here for 13, let's see, this looks like a sine graph, so we know we have y equals, and our amplitude looks like it's 1, 2, 3, so y equals 3 sine. And then we're going to have to do our 2 pi over b again. And it looks like we're completing one whole cycle here at pi over 4. So what in the world would b have to be? Well, it looks like it might have to be equal to, we can do our cross multiplying, or we can think about values that I could let be, so that 2 pi over that would reduce. It looks like it's probably going to be an 8. So here it looks like we have 8x. Okay, moving on to the last problems. We're going to look at these graphs, and it would be helpful for you to go back and look at your note-taking guide. So think about, if we're talking about secant, then what we need to do whenever we go through and graph this, we need to think about all of our values for cosine. Where cosine was 0, then secant would be undefined. So let's see if we can think about where cosine was 0. Well, cosine was not 0 at 0, it was actually 1. Well, pi over 2 was a place where cosine was 0, so the reciprocal of 0 is going to be undefined. So we have an asymptote there. And then at pi, cosine was -1, and so we have that value there. And then I will go back and move those to account for 1 plus here in just a minute. And then let's see, our next value that where we would be undefined would be here at 3 pi over 2. Okay, and then at 2 pi we would have 1. And then back through this other side, we have here negative pi over 2. And over at negative pi, we're going to have here -1, 3 pi over 2. And then at -2 pi, we're still all the way around. So notice all of that in purple, that is just our secant. But we need to move all of these values up 1. So if I do that, notice that these values actually shift up to here, and I'm going to see my secant value there. This one down here at -1 is going to come up here, and then you're going to see secant there on the 0. And then if I shift this one up 1, we're going to see that there, here. So notice that we are really just actually picking up all those important points, and then we need to move them up 1. And so we have the graph of secant, or 1 plus secant x. Okay. Now for this graph, we have to remember some important points for sine. And so sine started at 0, and sine of 0 is 0. So if we do the reciprocal of 0, we're going to get undefined, so that means we have an asymptote here. And then we go over to pi over 2, and sine of pi over 2 was 1, so the reciprocal of 1 is still 1. And then at pi, sine was 0. And then at 3 pi over 2, sine was -1. And then at 2 pi, sine was 0 again, so we have that. And remember, these we do flip over. It's going to look something like this. And then here we're going to be squeezed in between our asymptotes. Do remember, you're getting as close to those asymptotes as possible, but you're not really equal to them. Let's see, at negative pi over 2, we're going to be at -1, negative pi, we have our asymptote. And then over at -3 pi over 2, which is really the same thing as positive pi over 2, we're back up at 1. And then negative pi over 2, again, we're back down to here. And again, do remember, we're going to have those, it looks like a lot of parabolas through here. Okay. Okay, and for our final problem, remember, cotangent's the reciprocal of tangent. If we talk about tangent of an angle, remember that is the same thing as having sine of an angle over cosine of an angle. So that's your tangent value. And so when we're going through looking at each one of these values, think about where did I have tangent to be undefined and where did I have it to be 0. So if we're looking at it from that point of view, then we need to keep in mind here, everywhere cosine was 0, that's where we got undefined. So do keep that in mind. Well, if we start doing the reciprocals for cotangent, well, let's go back and think about, well, cotangent, if it's the reciprocal, then we can flip that over. Instead of thinking about this as sine over cosine, we can think about it as cosine of x over sine of x. And so if we do that, then we can figure out very quickly where we're going to have our asymptotes, because that's going to be where sine is 0. Well, sine is 0 at 0. So, oh, we can't see that. Let's change to a brighter color. So that means that this is going to be an asymptote at 0, because here cosine at 0 is 1 and sine at 0 is 0. So 1 over 0 is undefined. Well, at pi over 2, cosine is 0, but sine is 1. So 0 over 1 is 0. And then at pi, that's where sine is 0 again. So we're going to have an asymptote. Here we're going to have another 0 because that's where cosine is 0, but sine is negative 1. And then at 2 pi. And then hopefully you remember how these really looked a lot like a tangent or a cubic function. And so we had something that was flipped around and looked something like this. So we had that, and then it was also over here. And then this just kept repeating itself all the way through. So here again we would have an asymptote at negative pi, and over here at 2 pi. And then we would have our zeros here and here. And again, we would continue that pattern. So hopefully this will help you for your test on Friday.